Okay, welcome everyone to the day two of Build AI Agent in 7 days. So today we'll focus on uh, the core part of building the agent here. Moving to just to recap, yesterday we discussed the aspect of the basic tech stack in building AI agent, and second was how do you find the right idea and the characteristic of that idea. Today, we'll focus on building AI agent and more specifically the context engineering that is required. We'll start with a small demo of a full-fledged agent, and we'll try to then reverse engineer that what are the prompts, tools, and other things that has gone into building this agent. I will come back and then discuss the context engineering aspect of building an agent, and then I'll leave last 15 minutes for any question. So today's session will be for 30 minutes. We'll go till 7:30. So we might have some time, let's say a couple of minutes there, and we'll later on stay here for 15 more minutes and answer any questions. So as a background, when the AI was sort of came into prominence in 2023, the core idea that we were doing was prompt engineering, that telling AI what to. And most of the time, the things that was experimented was what exactly to say, what context you put it in the prompt that AI to act. In 2024, things evolved a bit. The definition, the concept of tool came that if you tell AI agents to take certain action and implement that tool, AI could take that action. So then the thing to be worrying about is prompt plus the tool interaction. Now in 2025, there's a lot of other things that are around when people have started building the whole agent. So there is the tools that you have to worry what instructions will go there. Then you don't want to stuff everything within the agent, so you keep something as a referential. So in some ways, you are giving a whole workspace for the agent to operate. So something will go in its system prompt, other things will be in its referential memory or knowledge base where it can read data from. It will have certain tools to take action. It could also, for example, go use MCP tools and among other things. So all of these comes in the window of context engineering, that you are not worrying about what prompt you are giving to the LLM, but overall what workspace you are designing for LLM to operate, including the tools, knowledge base, and all other associated things. So why do we still pay attention to the context engineering? Because one of the criticism is the model context window has become so huge, like 1 million for the case of Gemini, and internal version of them has 10 million. But still what we have seen in research paper and other cases is accuracy is often higher with lower context. So if you are really careful of what you put into the agent environment, you are more likely to achieve better outcome, even though you can stuff a lot more stuff into it. That's why we are today will focus on how to do this context engineering in the right way. So let me do a demo of an agent where it has a memory that it can remember across session what has happened. It can make certain tool calls to visually generate image or ask MCQ question. And it has freedom to extrapolate among other things. And then we'll look at the prompt that has been used to construct it. Hello.
Hi, Ajitesh. Great to have you back. Today, we'll dive into another classroom scenario and sharpen those escalation strategies together.
That sounds good.
Take a moment to think about how you'd approach Mia's off-topic interruptions. Once you choose an option, we'll break it down together.
Could you explain the situation a bit more to me?
Absolutely. Let me paint a clearer picture of what's happening. You've got a 7th grade social studies class. You're teaching a lesson on American history at the whiteboard. Mia, a bright and enthusiastic student, keeps popping up with her hand raised, eager to share thoughts, but they're off topic. She's asking about TikTok trends or movies, interrupting the flow of the lesson. She's not trying to cause trouble, she's just full of energy, and her thoughts spill out. The challenge is keeping the lesson on track while honoring her enthusiasm and find the right way to respond in the moment. Now, based on that picture, how do you think you'd respond? Great choice, Ajitesh. Acknowledging Mia's enthusiasm and setting a boundary is a solid first step. Now let's go deeper. Imagine you've done that, but Mia interrupts again. What do you think would be your second step if that gentle reminder doesn't work? And if that second step still doesn't solve it, what would be your third?
Yeah, that's a tricky question. I think my second step would be to maybe give her a task in the class to solve that keeps her busy. I think likely that would solve, and then just after the class, I'll have the discussion again.
I hear you, Ajitesh. Giving Mia a constructive task can help redirect that energy. But let's push it further. What if she's still off topic or interrupting even after that task? This
Here. So in this case, it will now do the analysis. So in this case, the agent remembered who I was. It knew where I left off in the last session. It had certain tools to paint a picture using image and MCQ tools. And all of this is sort of things that we'll discuss in the context engineering. A lot of these concepts we will discuss with an example of what you could do in Tuftung AI. But the basic concept applies across, whether you are building these agents on top of OpenAI directly or using Claude or using P Retail and other solutions as well. So let me walk you through the prompt that I wrote for this particular example. And the core aspect is here in the AI instruction. So I gave, this is the system prompt that went in here, that what is the role and character here. I defined the session flow, that this is how the session will work. You would notice that in many of the cases, I have used markdown structure in writing, which makes it really clear for the agent on how to follow it along, which are sort of the most important things. So we'll go through these in details later on. And then I have defined what rubric it should use to measure. And then memory I have, for in our case, we just is a tick box, but we'll discuss the concept of how we have created it. And then I have given it certain tools like MCQ tools, image generation tool, which it used today in this particular session. So coming back to this example, so this the three things that we discussed yesterday that an agent has. The agent must need to have some tools to take an action. The agent need to have a reasoning agent, which is the LLM, and then agent need to have state. In the case of the context engineering, you work on all three aspects rather than just the prompt. So I showed you the prompt that what I wrote with instruction and all. There is a message history that across every time I'm saying, which is hidden from complexity, but it's maintaining that what I said before and what I am telling now. There is a tool instruction that is there, a system prompt that when to use MCQ and other. If I look at the tool itself, we implemented a tool that when agent asks us to generate an image, we use Nano Banana or other models to generate an image. So that is the tool aspect of it. And then there is a state that it remembered that I'm Ajitesh, I came today for this session, and last session something was covered. In this particular case, we did not attach a knowledge base, but that is also something that you could do to an agent. So these will what we go through some patterns today, which will be a bit theoretical. We'll try to give an example so that you understand. But all of these patterns have become really popular in creating any type of agents when it comes to achieving a particular task. I'll then ask Raj to walk you through that how we do when you give us a requirement or AI instruction, how do we translate to the model layer and sort of its general applicability to other agent frameworks.
Yeah, thanks Ajitesh for the nice demo. And by the way, before we go forward, I want everyone to take a moment and appreciate what all just happened here in the demo. So a lot of things are happening behind the scenes. It seems like we wrote some English and an agent came into the picture. It had memory, it had state. It also was able to draw images and so on. But the eventual framework that it's working on is what we discussed yesterday and what is shown in the diagram here as well. There is a model, it is attached to tools, and it like the rest of the things where your voice, the mic, speaker, as well as the visuals, they are connected through some sort of platform, which we currently are using Tuftung AI platform here. So yeah, just take a moment and appreciate it. And we can go forward into some more detail today. As we already mentioned, that these concepts that we are discussing, especially like the context engineering part, which is most important part, like REST is a lot of infra and the rest of the software engineering stack. They apply to any sort of agent framework. And the keywords here are how to write effective tools, how to write effective prompts as well, and how to connect them with tools, and then how to connect them with external data sources, which is like there was a section for knowledge bases as well as some section for memory. So these concepts would be common. How they would be applied would differ from platform to platform. And in this platform, in this 7-day exercise that we are doing, a lot of these things would be done by natural language itself. So we don't have to write a lot of code, but we would go to code as well to make our final app, we'll cover tomorrow. But yeah, tools, again, system prompt, there is a lot of knowledge that will come into it. How exactly you want the agent to behave in a certain way, data sources, memory. And now this is sort of behind the scenes picture of what is going on in the layers of the stack. So at the most bottom layer, we are already familiar with OpenAI, Gemini, and all these big players who train the real LLM models or the foundational models, which we say. And we learned yesterday that there are of two types, like the text-to-text ones, which can also sometimes process images. And then we have the real-time ones. And on top of that, there are certain players which give you infrastructure to help you process audio and visuals. There is the key names are LiveKit and PipeCat. But even after that, if you want to use that infrastructure in your application, you need to write enough amount of front-end, back-end management, stateful services. So those are the two bottommost layer. And then when we go a little above, there are certain services available in the market, which sort of give you different versions of low code to high code sort of solutions. And you can call them the platform layer. And some top layers are WAPI, or there is some micro one as well. But these are sort of, they are in a spectrum. And that spectrum could be that they are close to as end applications, or they can be as close to as LiveKit and PipeCat, that they give you the infra. One thing that we want to highlight here is that while using Tuftung AI, we are quite we cover this platform spectrum very broadly. You can use it in a low code way, and you can also use it in some sort of a higher amount of code way to build your own applications. All right, moving on. So like in our case, there are certain things that this voice agent stack is doing behind the scenes, and what are the components which it's using. This slide sort of represents that. So when you write a system prompt, or when you write sort of the requirements on the left side of this edit scenario, we have to generate some system prompts. We have to figure out which tools we should be using and how to attach them. Some tools also require some additional data, which is also inferred from your prompt itself. And it is a multi-turn sort of approach, which goes on a couple of times throughout your original requirements. And we also figure out what memory and guardrails to place. And this is a separate agent which takes your requirements and transforms it to build the voice agent itself. And this voice agent is composed of these many parts: guardrails, tools, memory management layer, system prompt, and so on. So that's what's happening behind the scenes. And finally, effectively, you get an agent which you can interact with on our platform, or you can also, we will learn how to take it in your application out of the platform.
So I think yesterday there was one question that what is happening behind the scene. So this is a sort of answer to that question. And the components that you see in the second layer, like guardrails, managing context, tool registration, will be same across you build on any framework. And that's what we are trying to represent here, that we'll be teaching you today the second layer here, that how you do effectively. Some of this is taken care of, but even if that, you understand that you might take better advantage of the tool if you know what's happening. Any questions till now? or we'll move to the next section, which will be some patterns in the context engineering.
Yeah. Hi, Aditesh. Had a quick question. Yeah, if you don't mind, could you tell me exactly what guardrails are? Are they like kind of barriers or something, or any sort of safety measures to follow, something like that?
Right, yeah. In a very broad way, for example, uh, if let's say violence and other kind of things could be out of that you don't want to address, right? So we will have those conversation blocked. Other could be if let's say it's an interviewer and you want it to switch the role back to the candidate, right? Hijacking the prompt. So that should not happen from the user space. So depending on the context, it could be very different sort of things. But guardrail sort of puts these rules that within which the agent has to operate, and nobody can hack that.
Right. Thank you.
So as an example, we have certain guardrails that if things go off script more than a few times, the agent ends the call.
Yeah, and like any public tool, the misuse happens all the time. So this becomes important, or there is a brand risk. So next we'll discuss some context engineering patterns. So this will be really helpful when you are writing your agent from now on. So many of you have already decided the idea that you'll be working on. So try to see in that pattern that how will you write the AI instruction, how will you, what kind of tools that you will use, and we will discuss those patterns and then also show you the example cases. So the first pattern is what you saw in the AI instruction that I was showing, that generally when writing AI instruction, use Markdown or XML tags. So these are has been shown that agent responds better to writing the prompts this way. In many of the meta prompter, including in our natural language and meta prompter, this comes out of the box. You write a natural language and we turn this into the prompt best practices, so you don't have to worry about creating this way. Some of the things you should not be putting a system prompt is like large data source. So that should come in the referential memory or knowledge base. And similarly, like procedures and all should come into the knowledge base, while things which should be same across the conversation, for example, role, personality, like these are the things will be required in every turn of the conversation. Those should definitely come into the system prompt itself. So going back to the example here that I showed you, if you look at the system prompt that is written here in the AI instruction, so this was the role and character which I had put. There was in this what language to use, what kind of personality it should show. And then at the bottom is also some coaching principle that it has to follow in doing this communication, including the teaching style, among other things. So that's the first part, that how should you write system prompt. So for example, if you are creating a meditation coach, so you should put the role that you are a meditation coach. This is the behavior. Maybe you are a calm person. You like to hear what other person is saying. You want to create a safe space. So all of these things should go in the system prompt in a structured way. The second sort of tricky aspect in the system prompt is that AI to a large extent is very helpful the way it's been trained. So whenever you have to make it a difficult to work with humans are in general, you have to do some extra work. So for example, whenever we create a coach kind of scenario, a coach does not accept the explanation on the face value. So for example, if the coach is a teacher and you say that I did not do the homework because there was no electricity, your teacher likely will not take it on the face value, right? Will ask some follow-up question. Similarly, if you are selling to a person, they will not just buy it, they will create some resistance. So in our case, and in most of the voice agent that you build, you will have to write these resistance and build into the agent framework. So for example, this is what we use and has seen working, so that whenever there is a proposal, you should push back 2-3 layer deep. So don't accept the explanation at the surface value. Similarly, often with the human, there is a teachable moment that let's say I'm not accepting what you are saying, but if you offer me enough explanation, I should be able to get convinced. For example, is it low cost or not? It's aligned with my values or not? So there will be some criteria that I will have. And so on all the teacher, meditation, therapist kind of scenarios that you are making, think of what is the breakthrough or the teachable moment that you want to write in the system prompt. And the third aspect is the creating pressure. And I just wrote 3 examples. There could be more. For example, there could be a difficult person to work with who just randomly asks out of the box question or like something that is not related to the system prompt instruction. So those things you should pay attention when you are creating your scenario. Study the user behavior and try to put it in the system prompt. So that is the second pattern that I wanted to highlight. And the third thing you should put in the system prompt in defining your agent is what is the flow, that how it should open the conversation. Then during the conversation, let's say the objection handling or this breakthrough when these conditions happen. And finally, what happens after that? There should be some change in behavior, maybe the next step discussed. Later on, we'll discuss a pattern where all of these 3 steps can be broken down into a sub-agent architecture for a very complex agent. But for a typical agent, you want to write down this flow behavior, that what happens in the different part. So for the agent that I demoed, in that case, there is a session flow defined right in the prompt itself. That there is a greeting, then you present situation, you ask MCQ, and you wrap up like this sort of pattern. It has to follow for each of the case. So that's the first pattern on the system prompt. This is the most part where you'll spend a lot of time and iteration. Likely for most of the creative scenario, on the first attempt, you will not get it right. But try to follow these patterns and you will 80% get there, and then might need more research. Any question on system writing effective system prompt? Okay, so I'll keep moving. I know this is sort of a theoretical aspect of our context engineering work, but yeah, once you are writing that, this will be super critical. One way to write the prompts is also like just take a download of the slides and put it into ChatGPT or somewhere. And these models are really good in writing the prompts itself. So that could be one way that you write your first version of the prompt. The second pattern or aspect of context engineering is defining a tool, and we have touched it upon a lot. But there are 3 aspects of the tools with respect to agent. The first is the tools are registered. The second is you have to add that in the system prompt. And third is the implementation. So in most of the tools that most of the platform you will use, the registration and the implementation would already been done. For example, in our case, we have already implemented the slide. Or the image generation and other, we do register. The only thing you need to take care is how to present it in the system prompt. So for example, you decide in our case to use image generation tool. So then as soon as you switch it on, we register the tool. If you auto add the instruction, then we automatically add the instruction. Otherwise, you could write down the instruction in the system prompt itself. So irrespective of the framework that you use, these are the 3 things you need to do. Some of the things the framework or the platform will take care of it. Other things you might have to do on your own. For example, if you are building a tool where scheduling has to happen, so maybe Calendly integration is not done and there has to be an endpoint which needs to be added. So implementation also you need to take care. And some of the other tools, for example, that what we showed, implementation is already done. So generally pay attention here in the system prompt that you give some example when to use this tool, how to interpret the result of this tool, and how to move, how often to use this tool. For example, image and slide has to be used more often. So those things you might want to put down in the AI instruction. Any question on the tool part? This might be one of the critical aspect as well of the agent context engineering. Okay.
Hello.
Yes, Priyal.
Yeah. So my question is that I just told that we have to avoid large data over here, right? So how much data is large data here?
Right. So yeah. So large data in some way, anything above It's qualitative, first of all. But yeah, if you're going more than 10,000 tokens, which is around 40,000 words,
Okay.
it is generally not a good idea. But try to be minimal, like just use, so one of the aspect of transformer architecture is that it pays attention to every token. So everything you put in there is important to the model. So you just should put in the must use things, and whatever is not must use or not required every time should go into the referential or external data source. So that is our third context engineering pattern, that now the agent has ways to reference things just in time. So for example, if I am building a therapist and there are 5 kind of trainings that I need to do, one is CBT, one is another, and so the manual of conducting maybe can go into the just in time reference or a knowledge base that the agent refers to, while the main part of the role and things will go into the system prompt. Now, this just-in-time things does come at the cost. So every time an agent make a just-in-time call, it's incurring like 300 to 500 millisecond. So it does not behave as real time, but that would be okay, depending on the conversation quality. So I'll just quickly walk you through that, how to use just-in-time in case of our portal. So every portal platform might have it different. In our case, if you go to knowledge base, you can upload the knowledge base here. And if you click here, so anytime the agent has booklet kind of information, it will refer and make a call before answering the question. So if you are creating a sales coach, likely will put the sales manual in the knowledge base. So those will become an external source that it will do just-in-time retrieval. But because there is a sorry, go ahead, Priya.
Yeah, you can continue.
Okay. So because there is a latency hit that it gets, one of architecture pattern that has becoming popular is the hybrid architecture pattern. That is, whatever is the most important thing, you should put in the system prompt. For example, metadata, that a fee booklet information is in the knowledge base, you should put in the system prompt, while the real system prompt or the real data you put in the manual. So in the case of Claude Code, which has become a really popular tool, the metadata about the skills is there in the system prompt, but the skill itself is referential, that it just in time refers. Our memory architecture is also very similar, which we'll talk about in the next slide. Akansha?
Yeah, I wanted to know that with respect to what we are giving the size in the database we are putting, right? Is there a constraint in that too? And like, does it matter how structured that particular data is? And if that data is, not very coherent overall. I know there are tools right now. You can do all of that for uploading the database, but I just wanted to understand your view.
Right, yeah. So this referential data source, there are a couple of ways. So in our case, we do a RAG, which is semantic retrieval based on like how related the information is. In the case of other platform, there is also search like regex. It will just search based on particular term. In other case, like Claude Code and Codebase, Codeage tool, there is a list file and it reads through. So it depends on whether these tools are being efficient in finding that information. As long as our RAG is able to find that information, it does not matter how structured that document is or is not. So maybe a good idea of test will be that you do a search using any experimental solution where you put as a RAG and see that whether you can find the related information or not. So as long as things are written nicely and things are semantic wise similar, it should work. In the case of code and all, general regex based search has given better results. That if you're looking for this function, then you should be able to find that function using the search. We can take the details also later on.
Yeah, but one quick rule of thumb, if your document contains tables, charts, images, and so on, then it's probably not good. But if it's in a story format, you can pretty much put a large amount of content and it should be very accurately retrieved on demand.
Yeah, natural language sentence.
Yeah, thank you. I had one more question that was again regarding the prompting, the context part. Like I'm not sure if you're going to cover in future as well the best prompting practices. But one thing is that you create guardrails, strong guardrails, which agent must follow in all situations. But then there are a few conversational practices which we want the agent to follow in terms of wait for the response, or how they have to speak numbers or certain word. But then there are like a lot of times you have to create a lot of negative prompts, instructions where what not to do. I'm not talking about guardrails, but don't pronounce number this way. But then there is a positive way of doing that as well, that pronounce number in this particular manner. My own experience has proven that.
I'm very sorry. Can I come back to you for this question?
Yeah,
I just want to go for content, and then in 2 minutes we can take this question.
you don't. I mean, if you are going to cover it later on as well, it's fine. You don't have to cover it today.
I know this is a really good question. I do want to come back to it,
Sure.
but just want to cover the main content first.
Cool.
So the second, another pattern that you should definitely pay attention is the memory aspect. So in our case, the memory is two-tier, which is very aligned to this hybrid architecture. So our agent decides what to remember about you, and we put that in the system prompt, which we call super memory. And then all the details is we put as a referential memory that agent can just in time call. This is if you are building agent on us and you want to control the memory, then you just go to your in memory and switch it on or switch it off. When you switch it on, by default, we remember previous conversation, some preferences, and what should be covered in the next session. That's what agent notes down, but you can tell the agent what it should be remembering. So those could be sort of tweaked from here when building the agent. Now, this again could differ on different platform, but there will be some aspect of memory that has to be there in order to build an agent that is doing long-term tasks. This is an advanced pattern that most likely might not be that useful. So one aspect is that anytime an agent is doing 10-minute plus conversation, we might need to summarize all the time. So this Tuck-Tongue AI handles automatically, and many of the platform like Gemini and all also handle automatically. But you could also like summarize and pass the context back to the agent. One thing is critical is that make sure that important things are being summarized and wasteful things are being forgotten. And the second aspect for large context or longer conversation is sub-agent architecture. So when I showed you like there is opening, closing, middle, and end sort of a conversation, there could be 3 different agents, and one agent only does its own part, and that way it's very token efficient. So in our case, this sub-agent architecture happens that if you select a super agent, so in that case you define a flow that there is a supervisor agent, and then there are different sort of agent which does different pieces. So this will be important if your one session goes beyond like 20 minutes or so, or is very complicated, you might want to consider breaking down the agent. But this pattern is also getting really popular for different agents, that you break down the agent into different flows which handles it. So some of these I just went over very quickly. What I have also done is there are example of different agents with different tools and prompts written. So all of this, if you click, you will get an example prompt. So that should help you write the agent. I'm also available, can take questions now, but during the day tomorrow and next 2-3 days, we will focus on helping you build the agent. So we will go deeper into all of these and how do you do the context engineering piece right. So that concludes the main part of the presentation today. Open to question now. I would want, so I know Akansha, you had a question, so we'll come, we can go to that. And us also, if you have a question, can drop it now. Okay, so let's start, Akansha, with your question. So I think your question was that in certain cases when the agent becomes so many if and but logic, right? Like mostly like an IVRS kind of solution that if there is a number, don't pronounce this and other. How do you prompt in that case, right?
Yeah, I mean, I just would like to hear what's your approach to that. And as you're the one, building the platform, you would have seen what works best, right?
Yeah, so in our cases, whenever this becomes, the agent becomes a lot more robotic whenever you do lot of rules. So either the capability of that agent, that might not be the best use case in some of the cases. In other cases, maybe the alternative is worse. For example, in the case of a call support agent, maybe no one is available and it has to do this task. We don't have a best we don't have a solution for this one, that how do we guardrails again all of these nuances. What we have seen is Cartesia and few other models have done a good work when it comes to not saying the numbers in a certain way or not pronouncing out the formulas. So maybe picking the right model will be one of the case, because this has to be handled in training layer in some of the cases. I don't know how much prompting will help in many of the situations. That would be my thought on this. Maybe Mayank would have some opinion.
Sorry, I was actually looking at some other questions on the chat. But yeah, regarding this one, the positive and negative part of prompting, like I hope we are there, right? Yeah, so what I have found is like you cannot get away without adding those negative things, which are the don'ts. So, but you have, if you do it too much, then the agent gets confused. So that is what I've seen. So typically I put the very key like 10 to 15 points, which are that don't do this, don't pronounce numbers like this, or don't talk about dates in a certain manner, and so on. But I keep it minimal, maximum 15 or so points. And then whatever I want to be the good behaviors, I put it in a critical section. And I would bias towards putting more of what to do versus what not to do. What not to do should be thought of as the 5 to 10 points only.
Yeah, cool. Thank you, Ajitesh and Mayank. Anyway, we'll cover more when we are, writing the prompts.
Yeah. But there was this other question on the chat regarding breaking down the agents. So I think the key idea is pretty simple, and it's also very human. So if you give a large book about all the philosophy and all the information of the world, and then ask to make tea to someone, then that person is going to be confused. And for the case of agents, so like if you have an agent which has to follow a 30-minute conversation, and there are 15 things to do in that. One thing could be to teach one concept, other thing could be to take a quiz, and so on. So we don't want the agent to be confused while it's doing one of the tasks. So that is the key point. Yes, Priyal.
Yeah, if I can just go over that one. So basic aspect is give enough context for it to do the job, and how to minimize it. And that's what breaking the agent is, that one agent has sufficient context to just greet. It knows that I'm meeting Mayank today, and I just have to say hello, and I have to set the context, and that's it. So it will do in the limited context window. It will keep taking notes that what it has done. It will transfer the notes that this is what I did to the next agent. Now, next agent has to only deal with the notes that that the previous agent transferred, and do its job, which is ask 3-4 questions, and keep doing. So this pattern emerged from coding agents. So like Cursor and all of these do long running tasks, and they keep maintaining a note. Like I created a plan, and here is the plan. And even if some things fail from thereof, things start. So when I say breaking the agent, I mean, yeah, the different flows or agents that you create to handle one particular aspect of it and hand over to the next agent. Priyal?
Yeah, so my question was on as in you just said that we have to prompt the memory part of the agent, right? So is there any structured way to prompt that if we don't want to go in the auto memory thing?
Yeah, so default one should be good most often, but default one makes a judgment on what to remember. So I think previous conversation and what next to do should be same across in many of the scenario. But the second aspect where it tries to remember what is the user preference, there you should think through. So if it let's say related to a personal branding, then remember their background or what is their goal. And what kind of brand they want, like those will be critical piece to remember, right? Similarly, if it's a meditation coach, then what kind of environment they are in, their cultural upbringing, maybe those things are important. So I think those second aspect of the prompting, you might need to spend some time, that what is critical for your user. Like when you are the coach or you are the person interacting, what are the things you like to remember about that user when meeting next? So those things you should put as a second bullet for it to remember.
Okay. And what about the aspects where we are not really very having an expertise in the domain we have already we have chosen to make our agent in? So at that particular point of time, what we can do, how we can go about it?
Yeah, so agent building has to be some UX research and some this. One is that you try a couple of times once you build and see that the behavior improves. But I would encourage like at least secondary research that what kind of notes your coach are making. Like if you take a peek at their Google Doc minutes of meeting, what are they noting down? So whatever they are noting down will be an important piece that the agent should also note down, right? Yeah, that's what comes to me top of my mind. For example, as an interviewer or other, you likely note down how did they perform, what are the strength and weakness, something like that.
Okay, thank you.
Vidya?
I have a question. Do we have a cap on the number of minutes that we can preview the agent?
So yeah, we will give you more. That you mean for building, right? So we will give.
Yes,
so we give 25 free minutes, but for all the participants here, you will get extra 50 minutes for every day. Like today, we'll give extra 50 minutes so that you don't get bottlenecked on number of minutes in launching.
Okay. And that's tied to this particular email ID that we use. So that's recognized. Is that how that works?
Yeah, we will use that too because we will use that to give to your account.
Okay.
Yeah.
Okay. Thank you.
Any other question?
Well, circling back on the previous question, so yeah, the domain knowledge that we have to put in the agent, that is something that we have to come ourselves. It's not, that is the hardest part actually, which is this gaining all the context and engineering it. We have a deep research option as well, which you click, which works, but it is not advisable to create an agent on something which you have just no clue of. There should be some secondary research involved before.
Okay. Rest of us want to state that we have concluded. So we'll be here and keep answering question. But people who want to drop, like that's also.
Yeah. So I had this question, as in I was going through the website of Tufton. I came across this configure access, the optional thing for the AI building when I was building my scenario. So what is that particularly for, like the configure access thing?
Right. So that is how do you share access with other people? So if you make it, let's say, available in certain duration, then only for public link, it will be available to user during that time. The other aspect is like auto recorded. So when you're conducting interviews, you likely want everything to be recorded, the video and all. So if you click that option, then it will record automatically the video We don't automatically switch it on because of the privacy reasons. We want to give our user the option to do that. And the third one is that whether your participants can see the result or not. So if you disable that, they could not see the result, only you will see the results.
Okay, and can we use that results for further, improving the models like automatically, or will we have to do it the other way around?
Right. So currently, we are internally building that. How do we create a self-improving agent where this transcript can be used to improve?
Okay.
But for now, like it has to be manual. So you see the transcript and you figure out, okay, the model is failing here, and accordingly change the prompt. We need, you need high quality data to do that, and that is something that we are trying to figure out what to pay attention.
Okay. Yeah. Thank you so much.
Okay, thank you so much, everyone. So we'll connect tomorrow. So tomorrow's goal will be to build the whole application, like start thinking about that. Thank you for joining today. See you guys.
Thank you so much.
Thank you.
Thank you.
Thanks a lot.
Thanks, Suresh.
Bye.